There was no announcement, no press conference, no sudden show of force. But inside defense planning circles, something changed quietly. Assumptions that had held for years stopped being written as certainties. Not because of a new aircraft rollout, and not because of a copied design. It was a deeper shift, one that doesn't show up in flyovers or spec sheets. Because the real advantage wasn't what could be seen from the outside. It was something buried far deeper inside the system. And once that constraint disappeared, the balance in the air stopped being predictable. What changed wasn't a single aircraft or dramatic unveiling. It was the removal of a limitation that had quietly shaped every comparison between Western and Chinese fighters. A constraint so fundamental that speed, stealth, sensors, all of it depended on whether it still existed. And as long as that constraint existed, the outcome of any confrontation was assumed. To understand why that balance is now being questioned, you have to start with a problem China could never solve. For decades, China's aviation industry lived in the shadow of a single, glaring weakness: Russia. While Chinese engineers designed increasingly slick and stealthy airframes, they couldn't build the one thing that truly gives a fighter its teeth: a powerful, reliable jet engine. The J-20, a fighter designed to challenge America's F-22 Raptor, first flew with Russian-made Saturn AL-31F engines. This wasn't just embarrassing, it was a strategic chokehold. The AL-31F was a decent fourth-generation engine, but it was never meant for a true fifth-generation fighter. It was underpowered and couldn't do the one thing that really matters: supercruise. Supercruise is the holy grail of fighter performance, the ability to fly faster than the speed of sound without using the afterburner. An afterburner is like a nitro boost for a jet, dumping raw fuel into the exhaust for a massive burst of speed. It's incredibly powerful, but it guzzles fuel at an insane rate. A fighter using its afterburner is a fighter that's heading home very, very soon. Without supercruise, the J-20 could never truly compete. It couldn't sustain high speeds to control the airspace, intercept threats from a distance, or run from a fight without burning through its fuel in minutes. It was a stealth fighter that had to choose between being fast and being able to stay in the fight. This reliance on foreign engines was a huge headache for Beijing. Russia knew it held a critical card and reportedly tied engine sales to other purchases, like their Su-35 fighter, an aircraft China didn't really want anymore. China's first big attempt to break free was the WS-10 engine. It was a massive effort, but the early models were plagued with reliability problems. They got better over time, and the later WS-10C variant finally gave the J-20 a respectable, homegrown heart. But even this was just a stopgap. It allowed for some limited supercruise but was still an underpowered, modified fourth-gen design. The J-20 was still a compromised machine. Its advanced stealth and aerodynamics were being held back by an engine that just couldn't keep up. To fix this, China needed more than an upgrade. It needed a revolution. And that revolution has a name: the WS-15. And for planners watching from the outside, this raised an uncomfortable question. What happens when a weakness stops limiting design and starts accelerating it? The WS-15, codenamed Amei, represents the culmination of decades of relentless effort to cure what Chinese media called its heart disease. Recent photos and official statement from late 2025 and early 2026 suggest the WS-15 is moving past the prototype stage and is reportedly in low-rate production, being tested on the newest J-20A fighters. This is the engine the J-20 was always meant to have, and it changes the entire equation. Let's talk power. The WS-15 is designed to generate a staggering amount of thrust, with reports placing it between 161 and 181 kilonewtons. To put that in perspective, this is in the same league as the Pratt & Whitney F119, the legendary engine that powers America's F-22 Raptor. This immense power is what finally allows the J-20 to achieve true supercruise, with a goal of sustaining speeds around Mach 1.5 without guzzling fuel on afterburners. So, what's the secret? The breakthrough is a technology that's incredibly difficult to master: single crystal turbine blades. Think of it like this: you could weld a bunch of metal scrap together to make a sword, but it would be full of weak points. Or you could forge it from a single, flawless piece of steel. That's the difference. These blades, grown in a lab as one continuous metallic crystal, can withstand temperatures and pressures that would shred normal alloys. This lets the engine run hotter and faster, generating more thrust more efficiently. For years, China struggled with this, with reports of engine prototypes failing catastrophically during tests. But it appears they've finally cracked the code. They now have the one component that can't be easily copied or hacked: The new J-20A variant, equipped for these engines, isn't just an upgrade. It's a completely different animal. It has the power to climb faster, accelerate harder, and stay in a supersonic fight for far longer. It also generates way more electrical power, which is critical for the next generation of radars, sensors, and electronic warfare systems. The Dragon has finally gotten its heart of fire. With the J-20A now getting its intended WS-15 engines, we have to ask the question in the title: does this make America's F-35 obsolete? The answer is more complicated than you might think, and reveals the deep differences in how these two jets were designed to fight. If you're just looking at pure performance, speed, thrust, and agility, the J-20A has now seriously closed the gap. The F-35 was never meant to be the fastest or most nimble jet in a classic dogfight. Its own supercruise ability is limited to a short dash at around Mach 1.2. The new J-20A, with its goal of sustained high supersonic speeds, can now dictate the terms of a fight. It can choose when to engage and when to disengage, a huge advantage in air combat. But saying this makes the F-35 obsolete is to completely misunderstand what the F-35 is. The F-35's deadliest weapon isn't its speed, it's its brain. It's a flying supercomputer, a stealthy sensor node designed to suck in a ridiculous amount of battlefield data, process it, and share it with every other friendly asset in the network. Its entire philosophy is see first, shoot first, kill first. The F-35's pilot isn't just flying a plane. They're managing a sphere of information, targeting enemies long before they even know they're being watched. But that advantage only holds if the network itself survives the opening minutes of a conflict. This is where the F-35 likely still hold a major edge. Its sensor fusion and networking are considered a generation ahead of almost everything else in the sky. While the J-20 has a powerful radar and advanced sensors of its own, the seamless integration that defines the F-35 takes decades of operational experience to get right. And the WS-15, for all its power, has a key limitation for now. It doesn't have thrust vectoring nozzles. The F-22 Raptor's engines use 2D thrust vectoring, allowing the pilot to point the engine exhaust up or down for mind-bending agility. The WS-15's current nozzles are fixed, meaning that while the J-20A is incredibly fast, it can't match the F-22's extreme close-range maneuverability. This is the part that never appears in press releases, but quietly decides how many aircraft are actually available on any given day. Then there's the massive advantage the West still holds: reliability. According to executives at General Electric, a top-tier American engine can run for thousands of hours between major overhauls. It's widely believed that even the best Chinese engines have service lives measured in the hundreds of hours. That's an enormous difference. It means for every hour a J-20 is in the air, it needs way more time in the hangar. A fighter getting an engine swap isn't a fighter on patrol. The story doesn't end with the WS-15. China has been working on another, equally important engine, the WS-19. If the WS-15 is the high-performance heart for China's top-tier fighter, the WS-19 is the engine designed to power the rest of the fleet. This engine is intended for the J-35, China's answer to the F-35. The J-35 is a twin-engine, stealthy fighter designed to operate from aircraft carriers. However, the prototypes and early models are flying with older Russian-derived or interim Chinese engines, like the WS-13. The WS-19 is the engine it's waiting for, the one that will unlock its full potential and, crucially, free China from any foreign reliance for its carrier-based stealth ambitions. This aircraft is a huge deal. A mock-up of the jet has been seen on the deck of China's newest aircraft carrier, the Fujian, for testing the ship's advanced electromagnetic catapults. In late 2025, Chinese state media claimed that jets like the J-35 had completed catapult launch and recovery tests, marking a massive step forward for their naval power. This two-pronged engine strategy, the powerful WS-15 for the J-20 and the versatile WS-19 for the J-35, shows that China is playing a long game. It's not just about building one perfect fighter, it's about building a whole ecosystem of them with industrial scale and complete independence. The arrival of these new Chinese engines changes the strategic math of air power. It's no longer a simple F-35 versus J-20 matchup. It's now a battle of industrial philosophies. America's focus on exquisite, high-cost, top-tier platforms versus China's focus on rapid iteration, massive scale, and good enough superiority. Let's look at the numbers. The US stopped building its premier F-22 Raptor at just 187 planes. In contrast, projections from institutions like the British Royal United Services Institute Ruzi, suggest China's J-20 production is surging, with some analysts estimating an annual output of around 100 to 120 aircraft by 2025. By then, China had already produced over 300 J-20s, significantly outnumbering the F-22 fleet. Some reports project China could even field 1,000 J-20s by 2030. While the US and its allies are building lots of F-35s, that fleet is spread across the globe. China's entire J-20 fleet is being built for its own air force, concentrated in one region. This creates a serious problem. Does a single squadron of F-35s, with their superior networking, still own the sky when facing 3 or 4 squadrons of J-20s that can now match them for speed and carry long-range missiles? This is the new reality. It's a battle where quantity has a quality all its own. An F-35 can only be in one place at a time. A massive fleet of J-20s and J-35s can challenge air dominance across an entire theater, potentially overwhelming defenses through sheer numbers. The old narrative of absolute Western technological supremacy, the idea that one American fighter is worth 5 of anyone else's, is now facing its greatest test. China has worked relentlessly to close the propulsion gap that held it back for 50 years. Now, its massive industrial might is fully unleashed. This brings us to the big question, and I want to know what you think in the comments. If a country had to choose today, which jet would it pick? The combat-proven, networked F-35, or the new, fast J-35, backed by the promise of mass production? Let me know your choice and why. I'm curious which side of that debate you land on. This debate is one of the most important defense conversations of our time. So have the WS-15 and WS-19 made the F-35 obsolete? That question misses the point. What has ended isn't relevance, it's certainty. The F-35's role as a stealthy, network quarterback is more critical than ever in a data-driven battle space. However, what is over is the era of the F-35's uncontested dominance. The sky is now a much more crowded and dangerous place. The WS-15 has given the J-20 the power it always needed, turning it from a compromised design into a truly formidable fighter. The WS-19, meanwhile, is poised to power a massive fleet of J-35s that will challenge the F-35 not just on performance, but on sheer numbers. China has done more than just build a new engine. It has solved its most critical strategic vulnerability and, in doing so, has fundamentally changed the rules of air power. The West's qualitative edge in areas like sensor fusion and engine reliability is still very real, but it's no longer a golden ticket to victory. The race for the skies has just entered its most critical phase, and the winner won't be decided by a single dogfight, but by the factories, the supply chains, and the industrial will to build the future of air power. The gap has closed. The real competition is just beginning.